Hello students, today we will discuss conservation laws. That means conservation of linear momentum, conservation of angular momentum, conservative force and conservation of energy. So first we will discuss conservation of linear momentum. It states that the total momentum of an isolated system is constant. That means no matter how strong the interactions among its constituents and no matter how complicated the motions, the total momentum of an isolated system is conserved or constant. So if a force F is acting on a particle of mass m, then according to the Newton's second law of motion, we know that F is equal to dpdt and ddt p is equal to mv, and mv is the linear momentum. So if no external force is acting, that means F is equal to 0. That means dpdt is equal to 0. So p, that means p equal to mv equal to constant. That means in absence of any external force, the linear momentum of a particle in any isolated system is conserved or constant. Next, we will discuss conservation of angular momentum. So it states that if net external torque acting on a system is 0, then the total angular momentum of the system is conserved or constant. So here the angular momentum of a particle p of mass m about a point 0 is defined as J is equal to r cross p, where r is the distance between the OP. So if the force acting on a particle is F, then the moment of force or torque about O is defined as tau is equal to R cross F. So first we differentiate the first equation with respect to time, that is dj dt is equal to ddt of R cross P. So here the dr dt cross p plus r cross dp dt. So dj dt is equal to r cross f, because the dr dt cross p is equal to 0 and dp dt is equal to f. So tau is equal to dj dt is equal to ddt of r cross p. So when the external torque on the acting on the particle is 0, that means tau is equal to 0. That means dj dt is equal to 0. So J is equal to, that means the angular momentum is equal to of the particle of any isolated system, that is conserved. Next, we will discuss conservation of energy. So first we will explain the kinetic energy and work energy theorem. So using the second laws of Newton's second law and from definition of work, we know that F dot dr is equal to m dvr m dvdt dot dr. That means suppose a particle is going from 1 to 2 point 1 to point 2, then the work done is suppose F. So the m into ddt of half v square dt, that means d uh, third bracket half mv square. So the work done on an external force F upon a particle is displacing from point 1 to point 2 is defined by, that means W12 work done by the external force W12 is equal to integration from point 1 to point 2 F dot dr, that is equal to half mv2 square minus half mv1 square. That means T2 minus T1. Here T denotes the kinetic energy. Next, we will discuss the conservative force and the potential energy. So first we have discussed the kinetic energy, then we will discuss the potential energy, because the total energy is equal to the kinetic energy plus potential energy. So for potential energy, we know that if the work done by the force in moving a particle from point 1 to point 2 is the same for any possible path between the points. That means if the force is conservative, then it is path independent. So the region in which the particle is experiencing a conservative force is called conservative force field. So P, that is F dot dr, that means the particle is going from 1 to 2, and this path, that means the P path, and here the particle is going from 1 to 2, that is Q path. So that is same for conservative force field. So that means the cyclic integral F dot dr is equal to 0. That means particle is going from 1 to 2, then return back to the 2 to 1. So if the force is conservative, then the work done on the particle around a closed path is always 0. And if the force is non-conservative, like friction or viscous force or air drag force, then the amount of work done around the different paths are different, and the closed line integral is not 0. So according to the Stokes theorem, cyclic integral F dot dr is equal to volume surface integral curl F dot ds. So if ds is not equal to 0, then curl F equal to del cross F is equal to 0. And if the force is equal to, we can say for conservative force field, minus del V. So V is the potential field. So then we can write that this is the del operator. We already know that it is I cap del del x plus j cap del del y plus k cap del del z. And del cross del V is equal to always 0. So this V is called scalar potential. So now using the above form of the force in the line integration of F dot dr. So the line integration F dot dr from 1 point to 2 point, that is V1 minus V2. So the work done by the conservative force W12 is equal to V1 minus V2. Now we will discuss the conservation of energy. That means the amount of work done by a force in moving a particle from position 1 to 2 is given by the change in kinetic energy. That means W12 for kinetic energy, this is T2 minus T1. And if the force is conservative in nature, then the work done by that conservative force, that is again W12 is equal to V1 minus V2. So V1 minus V2 is equal to T2 minus T1, or T1 plus V1 is equal to T2 plus V2 is equal to constant. So the conservation of theorem states that the sum of the kinetic and potential energies, that means total mechanical energy of a particle, remains constant in a conservative force field. This is known as law of conservation energy. Thank you.